All right, so we're back here. This will be our last little instructional video. And we're going to start, we kind of talked about this in the last problem set, but we start talking about issues related to sample size. And when we think about sample size, there's, a couple things that we usually want to figure out. Usually we know that larger is better, right? In most cases, this is going to be the case. Having said that, though, this can't always happen. Can't always happen. As much as we would like to sample every single American, we can't do it because it's really, for a number of reasons. One, it's going to be the cost. So social science research and getting data and paying people for time and developing survey instruments is really, a convoluted process, and it costs thousands and thousands, hundreds of thousands of dollars, depending on what you're trying to do. And so we can't always do that. But you also have to make decisions about how precise your results want to be. Do you want a really small standard error, or do you want something that is relatively, big? You'll recall, that the way that we figure out standard errors, right, is, with this formula. But this little square root radical right here tells us that there are diminishing returns with sample size. And so while there's going to be a big difference between 100 to 500 people, the difference between 500 and 5,000 will be smaller, as well as 5,000 to 10,000. So the return for more precision may not necessarily outweigh the cost of the survey. Or whatever other study outweigh a financial cost. Plus there's time involved in getting to do with that, right? These decisions are also made by the level of confidence one wants. So whether that's 95% or 99%, and like the how sure and how wide or narrow a confidence interval should be. And so it becomes really important that with like many grant applications, like every time that I request money, is that we need an estimate of the sample size, because it affects what we can do in a study. So how do we go about this, right? So even though we want larger, there are a few little notes that we have to keep in mind. So one is for population proportions, and emphasis on this word, proportions. This is not a mean, we're talking about a proportion. So in this case, then what we try to figure out is, so n will represent the sample size that we want, is divided by the estimated proportion that we're looking to find times its complement multiplied the z-score of the confidence that we want. So this is going to be values of like 1.96 or whatever, and divided by the square of the margin of error that we want. So if we did like in a little example here, right? So in most cases, this is going to be like 0.5 because it gives us like the most uncertainty. We can get the largest sample, and there's we're basically saying it could be either or, right? This is going to be the CI level z-score. So this is going to be things like 1.645 if we're doing 90% This is going to be 1.96 if we're using 95%, or 2.58 if we're doing 99%, right? And this is going to be the accepted margin of error. And this is going to be, let's say we want to be within 0.07 or 0.01 or whatever, right? So this helps understand the precision that we want. So you can see that outside of the cost aspect, right, this formula builds in everything, the precision, the confidence interval, and like the value that we're trying to estimate, all into one like little formula. Now, another note that we'll make here is that there is a different one for calculating population means. It is not the same formula, and it is different. So the way that we would end up calculating this one, we'll use orange for this. So again, we're trying to find n, the sample size, is divided by sigma squared times the z level divided by the precision. So in your notes, the way that I have those listed is that this is the standard deviation, but note that because there's a square here, this is also the variance of what we're putting in here. This is the z-score that we already talked about in that last little formula, and this is the margin of error we'll work with. So should be pretty easy to calculate, and we'll talk about how to do some of those in some applied work in the next video.